Hey there, welcome back. In this video, we're going to go over a review of inverse trigonometric functions, or inverse trig. It's all towards learning the derivatives and eventually the integrals of inverse trig functions. Let's review. So we're first asked to evaluate each. So we're told to find the arcsine of 1/2. Okay, so arcsine is the same as saying sine inverse. So if you're used to seeing this notation, it means the same thing. What this means is we want to know the angle when plugged into sine that gives us 1/2. We're used to saying the sine of an angle equals, and then using our unit circle and getting the number. Now we're going in reverse. So I like to set this equal to y, or that, doesn't matter, either way. And so we translate that into saying the sine of some angle, we're getting the angle out, y, is equal to 1/2. Now, there's a bunch of angles that do this. So when we're dealing with inverses, we're restricted as to what angles we can use. For sine, we're restricted from -pi/2 to pi/2, and that's because all the sine values happen nice and continuously from this value, -pi/2 to pi/2. So where is sine equal to 1/2 on this interval? It'd be right here at pi/6. So that would be pi/6 is equal to arcsine of 1/2. Cosine inverse of -√2/2, that's the same as saying, well, let's set it equal to y. The cosine of y is equal to -√2/2. Now, what interval do we use for cosine and determining the angles? Because again, there's many angles where the cosine of that angle would give us -√2/2. Well, cosine is restricted from 0 to pi because from here to here we get all the cosine values on a nice continuous loop, if you will, that arc. So -√2/2 happens right here, and that would be at 3pi/4. So that is our answer. 3pi/4 is the cosine inverse of -√2/2. Arctan has the same exact bounds as sine does. It goes from -pi/2 to pi/2, just doesn't include the endpoints. And so we're basically saying that is equal to y. So the tangent of what is equal to √3/3. Now this one's a little tougher, but I look at that and I say, well, it's the sine of something over the cosine of that same angle. Needs to equal, well, it's the only way that we can get a smaller number over a larger number is if I have a smaller number over a larger number. That's how I think of that. And the only kind of question you're going to be asked by hand are questions that have to do with the nice unit circle values. So this would be 1/2 over √3/2, a smaller number over a larger number. So when is sine equal to 1/2? We already saw at pi/6. That's also when cosine is equal to √3/2. And so our answer is pi/6. Nice! So quick review on determining arc trig values. So I've got a big table here to go over just briefly. And the question I ask is, what is up with these functions in their restricted ranges? So I've gone over those restricted ranges on the last page where cosine, for instance, when we do cosine inverse, is restricted between 0 to pi. And that's because all the cosine values, again, are found from 0 to pi, right? You get every single value the cosine could be on this continuous arc. And this way, if I say the cosine inverse of 1/2, you're not like, well, there's infinitely many angles where that would be true, where we get 1/2 out for cosine. Yeah, when we restrict it this way, there's only one value. Okay, so in general, sine inverse, tan inverse, and cosecant inverse are all from -pi/2 to pi/2 with a couple variations. Tan and cosecant, tan can't be pi/2 or -pi/2 because cosine of pi/2 or -pi/2 would be 0 in the denominator. Cosecant can go from -pi/2 to pi/2, it just can't equal 0 because that's 1 over sine, and we'd have a problem there. But here's the main point of this table. Check it out. If your teacher absolutely needs you to study this stuff, think of your unit circle, right? And think of the fact that sine leads all of these functions here. You have sine y over cosine y. And so the only thing that we can't have is when cosine is 0, but that's only going to happen when we get to -pi/2 or 2pi/2. That's why it's strictly between those two, but not including the endpoints. Sine takes on all of its possible values from -pi/2 to pi/2. And the same with cosecant, which is 1 over sine. So as long as y doesn't equal to 0, we're good, because then we get 1 over 0. But otherwise, we hit every cosecant value. So what I have here is basically the communication that sine inverse x equals y. It's the same as saying arcsine x. It's the same thing. If and only if sine y equals x. So in other words, you're saying y is the angle, x is the ratio. So sine of y equals x. Y is the angle, x is the ratio. So tangent of the angle would equal the ratio. So just think of this as your table saying, all right, This is how to translate it into some more common sense, easier to read, rather than an arc trig function notation. And that notation and this notation mean the same thing. Now with the cosines, I talked about how all the cosine values are hid from 0 to pi. Cotan is led on top by cosine. So we've got cosine y over sine y, so as long as y isn't equal to 0 or pi, this doesn't equal 0, and we hit all the cotangent values. Secant inverse, which is the same as arcsecant, can be rewritten as secant y equals x. That's the same as 1 over cosine y. Okay, well, as long as y doesn't equal pi over 2, this cosine's not going to equal 0, and we won't have a problem with that fraction. So overall, again, the big things to remember are those restricted ranges because of the unit circles and the fact that we want to cover all the possible values that sine or cosine can hit once. And again, the other big piece of information is if you see cosine inverse or sine inverse or whatever inverse, it's the same as arc, that value, and you can rewrite it in terms of the other way, almost like you're doing with logarithm functions and switching it up. X and y switches in inverses. So you get cosine y equals x. All right, that's it there. Let's keep going with the review. So how do we evaluate problems like these? You're not allowed a calculator, so what do we do? Well, the first thing to look at here is basically ignore that cosine and just take this part and think, okay, if arcsine 4/5 is our expression, that's the same as saying sine of some angle equals 4/5. Now the best way to look at this, since it's not a nice unit circle, is doing a triangle, right? Like going back to your right triangle trigonometry. So we got a right angle. We know that sine is opposite over hypotenuse. And so if it's opposite over the hypotenuse is 5. And I'm going to just arbitrarily put y here. You could have put y there as well. It doesn't matter which angle. That's got to be a right angle because it's trigonometry and we're dealing with right angles and right triangles. 4 is the opposite to y. And then to figure out this length, which is not drawn to scale, all we need to do is very simply use the Pythagorean theorem. So we get 4 squared plus, I'll call that x squared for the unknown amount, equals 5 squared. And when you solve that out, you'll get x squared equals 25 minus 16. That's 25 minus 16 is 9, so x is equal to 3. So that's how we get that value of 3, not drawn to scale. So what do we have here? Well, we now have a triangle that's representative of arcsine of 4/5. So now we want the cosine of that angle, of y essentially. So basically now saying what's the cosine of y? Because that's what we've established. Well, the cosine of y is adjacent over hypotenuse, and that is 3/5. That's it. So you create a triangle based on the arcsine or arc trig. That's here. And then you deliver what the cosine or sine or whatever this ratio is that we're asked for based on that triangle. Let's do the next one. Arcsecant, of negative 13 over 12. Okay, well if it's arcsecant, that's the same as saying 1 over cosine of y equals negative 13/12, right? Because secant is 1 over whatever the value is. Let's flip it. So cosine of y is equal to 12 over 13. I'm going to write that as just negative 12 over 13. And so if you're looking at a triangle, remember it's arc cosine. If it's negative, we're dealing in the second quadrant because that's where cosine is negative, not drawn to scale at all. I'm going to arbitrarily put y there. That's where I normally put it. And now what I do is I say, well, if it's negative 12, that's here. We're to the left 12. That's why it's negative. Think about it on the unit circle or the coordinate plane. We're to the left 12. 13 is the hypotenuse. And again, this is adjacent over hypotenuse because it's cosine. That's how I know the 12 goes here and the 13 goes there. We could have put the y here. It doesn't matter as long as you follow adjacent over hypotenuse. Now, from here, what we're going to do is we're going to solve for this unknown value. So that's going to be negative 12 squared. We'll call it x squared again, equals 13 squared. Pythagorean theorem will solve for this missing value. That's 144 plus x squared equals 169. Subtract 144. X squared equals 125. Right. Equals 25, so x is 5. Okay, that's positive because it's upwards. So it's positive 5. Now, from here, we're told we want the tangent of that triangle, of this angle, because this is an angle, y. So now the tangent of y is equal to the opposite over the adjacent. Opposite of y is 5. Adjacent to y is negative 12, so you get negative 5/12. Go in pieces. Find the triangle, do the ratio based on that triangle. All right, last but not least is how do we deal with this now if we've got algebra? Oh no. And we're going over all this just to set yourself up for the proofs of the derivatives of arc trig. So if you don't have to do any of that, You might not need any of what I'm going over right now, to be honest, but I want to cover for everybody's needs, no matter who you are. So if you're in a more challenging class, this might be necessary. So again, we're going to fill out a triangle based on this. Remember, this is saying the tangent of y is equal to x over 5. That's what this says right here. So I use a triangle. I know this is going to be the opposite over the adjacent. So I just draw an arbitrary right triangle that x is not going to be solved for. And I put y here arbitrarily. I always put the angle down there, but you could put it up here. So opposite of y is x. Adjacent to y would be 5. That's adjacent to it. That's opposite. Now we do need to solve for the hypotenuse. Well, to do that, you literally just square each of these numbers. So that would be x squared plus 5 squared equals, and I'll call it h squared for the hypotenuse. So the hypotenuse would be equal to the square root of x squared plus 5 squared, square rooting to get h alone, which would be x squared plus 25 inside the square root. All right, now, this is the triangle. That's what arctan of x over 5 provides for us. Now we need the sine of this triangle, which is opposite over hypotenuse. So opposite is x, all over the hypotenuse, which is root x squared plus 25. Don't you dare rationalize. Just leave your answer. And that's it. So again, form the triangle just like we did with the numbers on the previous page, then take the sine of that triangle. Cotangent. Let's do this. Arc cosine of root x. Well, that right there is saying the cosine of y is equal to the square root of x all over 1. All right, let's put it over 1 just so that we have an adjacent over hypotenuse. And again, I'll just make an arbitrary right triangle. I'm going to put y down here for my angle. It's just where I do it to be consistent. And now the hypotenuse we know because it's opposite over it's adjacent over hypotenuse. So adjacent is, well, root x. And let's make that little blip right there. And then the hypotenuse is 1, so adjacent over hypotenuse. Now to find this, we need the Pythagorean theorem. Again, I'll call that just, well, I don't know, a. So a squared plus root x squared equals 1 squared using the Pythagorean theorem. So now I've got, well, a squared plus x equals 1. So a squared equals 1 minus x, and a would equal the square root of 1 minus x. So now that a value right there has become the square root of 1 minus x. Now why is that important? You were asked to find the cotangent of this, that triangle basically that we got. That's an angle. So the cotangent of the angle represented in this triangle. So I've got the cotangent of y, which would be adjacent over opposite. Adjacent over opposite. So that would be root x all over root 1 minus x. You could write that as the square root of x over 1 minus x if you want, but I'm fine with that. All right, ladies and gentlemen, that's it. That's a really heavy review of arc trig. Do you need to know it all? Some teachers don't need you to know barely anything in the first page. Just being able to find arc trig is important. So if anything, make sure at least to know that, where you're saying arcsine of a number means sine of what gives me that number. All right, I'll see you in the calculus part. Peace.